I've been using Blocky DNS for a while. I set it up as a service on my laptop and configured the network manager to use localhost as the DNS server. As the name implies, Blocky allows me to block stuff. I can avoid seeing nasty stuff like ads, suspicious websites, gambling sites, and porn sites. Blocking the right domains can even prevent trackers from tracking. What is DNS, you ask? DNS stands for Domain Name System. It's a way of making internet addresses more readable and memorable. Without DNS, you would have to type 122.199.22.154 instead of just zacoons.com. It's like a phone book, but for the internet. It's a bit more complicated than that because scope creep, but that's outside the scope of this video. By using a DNS proxy, you can rewrite some of those addresses to bogus like 0.0.0.0, or you could even add new addresses for your own personal use. Blocky DNS was great, but a few things bugged me. Firstly, it feels a bit slower and heavier than it could be. Secondly, it would refetch the block lists every time I turned on my laptop. So a couple of months ago, I skimmed over the DNS specification, and I was like, this wouldn't be too hard to implement. Oh, what a naive fool. I implemented a bunch of the core protocols, and the good news is that mine is like 10 times faster than Blocky. The bad news is that I found this other DNS proxy called dnsmasq, and mine is not really that much faster and uses way more memory for large block lists. With a block list of 1 million domains, each domain being around 20 bytes, that should be about 20 megabytes of memory, right? Wrong. It uses 3 gigabytes of memory for some reason. After much pain and investigation, I discovered that the reason it was taking up lots of memory is because I was using a tree-like data structure, or a tree, if you want to be fancy in French. This allowed for efficient lookups. In theory, this would be a more efficient way of storing the domains because there's less replication of labels. But in practice, each item has to have its own hash map of its children. Each hash map is about 50 bytes, and each hash in the hash map is 8 bytes. So for a tree of 1 million domains, with each label having a hash map of its children, that's around 200 megabytes of memory. Later implementations that I wrote were about that much. So then I was like, hey, what if I store this tree in a file? And I spent some time trying to implement this, but it turned out to be way more complicated than I wanted to deal with. Then I tried implementing the tree in memory again. Then I tried flattening the tree, but that loses the relationships between items. For example, to check for zacoons.org in this database, it would start in the first column, yup, and then move to the second, yup, so it would falsely return true. Then I tried implementing the tree in memory again. Then I tried a file-backed database again. Then after weeks of racking my brains, I finally found the perfect balance between memory usage and efficiency. First, it reads the file into memory. This is pretty much all the memory it needs, all allocated in one go. Then it reverses the labels and sorts the list. Now to iterate over it, you slice the query to the first label and find the upper and lower bound in the sorted list. Then expand the slice to the next label. Then we iterate again, but this time there is no match. So we modify the query to see if there's a wildcard. Try again. Nope. So we try again with a wildcard. Yes, the wildcard then consumes as many labels as needed until it matches a label or reaches the end of the string. After melting my brain writing this convoluted recursive function, I tested its performance against dnsmasq once again. So I threw away that week of work and tried something simpler, which I implemented in less than an hour, which outperforms dnsmasq by an okay margin. The downside to my new approach is that you can only have wildcards at the start of the domain name. After optimizing the database, I think it is ready for use. It is called DNS Shield. If you decide to try it out, make sure you keep an eye out for updates because there are still a few fixes and improvements that I need to get done before officially releasing version 1. If you find this or anything else I do useful, please consider donating. If you want a more fully featured DNS proxy, I would recommend dnsmasq.